Hello everyone, this is Reddy. Welcome to my channel on science, technology, environment and climate change. Today we'll be discussing on one of the important topics pertaining to climate change, that is enhanced rock weathering. So broadly speaking, this topic comes under environment and climate change, and in that it comes under a mitigation of climate change. So under mitigation of climate change, we have many natural and artificial methods like carbon capture and etc. So this comes under geological method of carbon capture. So let us dwell into the topic. The first question comes as, what is enhanced rock weathering? Well, it is a CO2 removal strategy where we use finely crushed silicate rocks so that these rocks will react with rainwater and or CO2 present in the atmosphere to form stable carbonate rocks and lock the carbon away for many years to come. So simply put, it is a geological method of carbon sequestration. And so it mimics a geological process that normally takes place usually. So what enhanced here means is that this rock weathering is actually a natural process, but it usually takes many years or millions of years together. But what enhanced here means is that we are fast tracking or accelerating this process. So how does this enhanced rock weathering works? Well, so what basically happens in this is that first we'll take a carbonate rock not carbonate rock, we'll be taking silicate rock which is crushed and scattered into a field, which could be agriculture field or it could be coastal lines. And then what happens is that as rain absorbs CO2 from atmosphere and falls in the form of carbonic acid, this crushed rock will absorb the carbon dioxide from the rainwater or directly from atmosphere to form carbonates. And these in the form of carbonates, they get fixed. So the carbon is fixed and it is not further released into atmosphere. And so in a way we are removing this carbon dioxide from the atmosphere. So coming to the chemistry, the rainwater absorbs atmospheric carbon dioxide. It becomes weak carbonic acid. Yeah, so this is carbonic acid. And when it comes to contact with calcium or magnesium rich minerals, this acid is neutralized and it produces bicarbonate. So here this is bicarbonate, and this bicarbonate ultimately precipitates as limestone, which is a carbonate with this formula, or any other carbonates in rivers, soils or oceans. So yeah, here it is converting in the form of argonite, which has the same chemical formula as limestone. So here enhancement simply means instead of rock, we are grinding it to increase the surface area, because all these reactions will accelerate with more surface area of the rock. So it is and the next question comes is, what kind of rock do we generally use for this enhanced rock weathering? One, basalt, which is an abundant volcanic rock, and it has been already tested in UK, US and Brazilian forms. And then we have olivine, which weathers even faster, but it is less common on surface. And next we have other rocks such as Wollastonite, mine tailings. This is the dust or rocks which comes after mining. minerals, and then we can also use crushed concrete. So let's just remember, if a MCQ comes in prelims, which of the following can be used as a rock for enhanced rock weathering? Just remember all these names. So apart from carbon capture, this enhanced rock weathering also has one more benefits. That benefit is that uh, spreading these crushed rock in agricultural feeds has led to higher yields and lowered soil acidity, because the basalt rock supplies magnesium, potassium, and phosphorus, which are essential crop nutrients. At the same time, uh, this basaltic rock replaced conventional lime. We generally spread this limestone, crushed limestone, in agricultural feeds in order to neutralize the acidic soils. So by replacing this conventional lime with this crushed basalt rock, there is an increased yield, up to 16%. So this enhanced rock weathering has dual benefits: one, carbon capture, and two, increasing soil productivity. So UPSC likes such topics, which has multiple uses. So yeah. And the final question: what is the difference between enhanced rock weathering and mineral trapping? Mineral trapping is just like a twin to enhanced rock weathering. Even in this, we lock away carbon by reacting with a rock. So what is the main difference between mineral trapping and enhanced rock weathering is that, one, as we know, an enhanced rock weathering takes place on the surface, whether being it in the agricultural land or being it in the ocean. So it is a surface process, whereas mineral trapping is mostly, it occurs deep underground. And second thing, in case of enhanced rock weathering, the rock will absorb the carbon dioxide either from the rainwater or from the atmosphere, which is a natural process. So here it is a natural CO2 absorption process, whereas in case of mineral trapping, it is our where we have to capture the carbon dioxide, let's say industrial carbon capture or some processes, and we need to pump that concentrated carbon dioxide into these rock layers. So here we need to pump the concentrated carbon dioxide, whereas in case of enhanced rock weathering, it's a natural process. And third difference is that enhanced rock weathering usually takes time, because we are letting the natural processes to take it, so it takes time. Whereas in case of mineral trapping, since we are injecting it deep underground under high temperature and pressure conditions, it usually takes place faster. So comparing the three: first thing, natural weathering, enhanced rock weathering, and mineral trapping. This is the fastest. So compared to enhanced rock weathering, compared to natural weathering. So this takes millions of years. Let's say it takes hundreds of years, and this takes a very few years for carbon capture. So with this, I think I have explained you all the basics of enhanced rock weathering. So here is a practice MCQ, which you can solve based on the above topic concepts. Please solve this MCQ and post the answer in the comment section. With this, we have come to the end of the session. Thank you. So climate change is real and it is happening as we speak. For a livable future, we need to stop the carbon emissions, or else, so we need to stop the emissions, and at the same time we must try to capture the existing emissions. Thank you.